Assalamu alaikum students. We are studying a course Disconnection approach or Retrosynthesis, and our topic is guidelines of the retrosynthesis. Today we will discuss the fourth guideline of disconnection approach. The fourth guideline includes disconnection must correspond to known reliable reaction or known molecule. What does it mean? Students, it means that while performing retrosynthesis or while doing the disconnection, you must be familiar with the known reaction. The reaction reliable. The reaction must be reliable. Or easily, you split the target molecule into those reagents which are easily available in our lab, or you are familiar with those reagents. So it is a mental approach, and this guideline is mainly focused on our previous grip on the synthesis. If we have grip on synthesis, then we will perform retrosynthesis, mean reverse of the synthesis, in very easy manner. So we will understand this point with the help of an example. Here is a target molecule. Students, we can disconnect it from next to heteroatom. As in first guideline, we have identified the functional group. Here is the functional group is carbonyl carbon and oxygen ester functional group is here. In second guideline, we have to disconnect this next to heteroatom. This is a heteroatom and this next to heteroatom while Jiggly line. Disconnect from here. Mean carbon oxygen ester bond will be disconnect. Here it is a arrow which is the disconnection arrow, and it will undergo or split into two fragments. The carbon attain positive charge due to electronegativity, oxygen attain negative charge, and this positive negative charge species is said to be the synthon. It will undergo to synthetic equivalents. Here positive species, here is the OH group will be added there, and here H is added there. Students, how we say that here OH is given, here H is given? This is a mental approach. We have to equivalent it. We have to make the fragments or make the reactants which would be the reliable. Now, just keep in mind how ester is formed. While before starting this disconnection, you must revise in your mind how ester is formed. When alcohol and acid is reacted and ester and water is formed, it is our basic concepts. So here is a acid, C double bond O, OH. This is a acid, and this side is alcohol or phenol. This acid and phenol, these are the de-esterify. Split. This ester is split into their simpler units or their simpler reactants or reagents. This is de-esterify. So it is based on our mental approach, as we know that acid, carboxylic acid and phenol are easily available in our lab, and we can synthesize our ester easily. So I hope you understand these guidelines. So students, another information, while the carbonyl species, when here positive charge appear and what would be the possible counter ions? The possible counter ions, the first one is the preferable to halogens like chlorine or bromine, then ester, then alkoxy OR, then Nr2 and oxygen or any metal. You can give it as a counter charge. Students, another example in which we will discuss the retrosynthesis and synthesis. Here is a target molecule. We see its disconnection. Students, it's our target molecule, and first guidelines, identify the functional group. Yes, here is a ester functional group. Second guidelines, you have to disconnect carbon next to heteroatom. This is carbon, this is oxygen heteroatom, and this is next to heteroatom. You have disconnect this bond and it would be a reliable carbon oxygen bond disconnect, and two species are generated. These are the synthon. This oxygen high electronegativity and negative charge appear there, and this carbonyl carbon low electronegativity comparative to oxygen and positive charge there. This synthetically equivalent and preferably to carbonyl species, the first preferable is halogens, and we have attached there chlorine, and here on this side H. So these are the synthetic equivalents. So it is a reverse manner, or it is a disconnection. What about synthesis? So these two reagents or reactants will react and they undergo to form a target molecule, and this said to be the synthesis. So students, here this group and this group, these two reagents are react. This oxygen having a lone pair attack on this carbonyl carbon, this bond shifted towards oxygen. Okay, so this is a mechanism in which this group oxygen is attack on this carbon and the negative charge appear on oxygen. So rearrange it. This oxygen will back there. This Cl, it is a good leaving group. It will leave the molecule, and this oxygen, which is positively charged due to 3 bonds, oxygen makes 2 bonds. Here 3 bond is paired. So due to this, it is unstable and positive charge appear there. This hydrogen will leave, and these electron left behind, and this positive species or positive oxygen is stabilized, and this target molecule is achieved. So it was a synthesis. I hope you understand this lecture. Kindly share your feedback. Thank you.